Hi everyone, so today in class we stopped on page 3 of your note packet. So I'm right at the part where it says review, okay? So how do we determine how many real roots a polynomial has? So this is something you know. Remember, we can tell the real roots or the number of roots based on the degree of the polynomial, okay? Now, we've always said that the degree would tell us how many possible real roots it could have. And we have to remember that complex roots always come in pairs. That's what we've been working on the last couple of days, meaning that if I give you root 6 is a root, then negative root 6, its complex conjugate, has to be a root as well. So because of this, we automatically know a few things. If it is a degree 1 polynomial, that means it has one root, and it has to be a real root. A degree 1 polynomial is a linear function, right? It can be a linear function. All right, a degree 2 polynomial can have two real roots. So it can either actually have two real roots or two complex roots, okay? One or the other, okay? If it's got three real roots, we can have, or it has a degree 3, we can have three roots. So we could have three real or one real and two complex. This should all make sense because of the idea of the complex roots come in pairs. If it's a 4th degree polynomial, it has four roots. So it could have four real, or it could have two real and two complex, or it could have four complex roots. All right, and so one thing you should see is that when the degree is odd, okay, if the degree is odd, there is at least one real root guaranteed, no matter what, okay? All right, so how do we find all of the real roots? All right, so we look at the polynomial, and we also look at the index. So this is the cubed root of 64. Now remember, we talked about these. So the cubed root of 64, we're looking for the number when multiplied by itself 3 times gives me 64, which is 4. All right, the cubed root of 8 over 27. Well, we talked about the fact that 2 cubed is 8, so the cubed root of 8 is 2, and 3 cubed is 27, so this would be 2/3. All right, but now we have a 4th root, okay? 4th root, so the square root of 256. So we might have to think about this a little bit, okay? 3 to the 4 power is 81. 4 to the 4 power is 256. So this would be 4, okay? But it is a 4th root, so that means that it could have both a positive or a negative real root, okay? All right, now look at number 4. The 4th root of negative 81. All right, well, because the index is even, we talked about this in class today, and this number under the root is negative, it does not have any, it's not possible. There's no solution here. We can't evaluate it, okay? All right, when we take the square root of a perfect square, we will get, this will undo the square. All right, now we can have a negative under the radical if the index is odd in this case. So the cubed root of negative 27 would be negative 3. So that's basically how you find real roots. But now I want to throw in a variable, okay? All right, so we're going to simplify each radical. We're going to go through a basic process. We're always going to simplify the number as we did previously. But now we got to take into account the variable. So we want to divide the variable by the index of the root. The result of that's going to come outside the radical as an exponent, so as the exponent. And any remainders stay inside as the exponent. And I'm going to do more of this later, okay? All right, so let's look at this. I've got the square root of 25x squared. Okay, so the square root of 25 we know to be 5. And then the square root of x squared we know to be x. Okay? All right, let's try this next one. The cubed root of x cubed y to the 6th. So I'm going to take the x cubed, I'm going to divide 3 by the index of 3, which is 1. It goes in evenly. So x to the 1 is going to come out. I'm going to divide 6 by 3. 6 divided by 3 is 2, no remainders, so y squared is going to come out. Hopefully you're seeing what we're doing now. All right, the 4th root of 16. So 2 to the 4 is 16, so the fourth root of 16 is 2. P to the fourth, so 4 divided by 4 is 1, it comes out. And then 8 divided by 4 is 2, so q squared comes out of the radical. All right, the fifth root of x to the 10, y to the 15th. We're going to divide 10 by 5 and we get 2, so x squared comes out. There's no remainders, that has to stay in. Y to the 15th, we divide 15 by 5 and we get y cubed. Okay, so I want you to try 5, 6, and 7. So I'd like you to press pause and try 5, 6, and 7 and then come back and let's check. All right, so you had the square root of 16x to the 8th. So the square root of 16 is 4. Remember the index when it's not there is 2, so we divided 8 by 2 and we got 4, so x to the 4th comes out. There are no remainder to stay in. All right, and the next one you should have taken 12, divided it by 4 and got x cubed came out. And then divided 16 by 4 and got y to the 4th power, which came out. All right, the last one, the cubed root of 27. 3 cubed is 27, so the cubed root of 27 is 3. Then we're going to take y to the 6th. We're going to take 6 divided by 3, and we get y squared. There is no remainder, so that comes all out of the radical. Now, what you might have noticed is that all of those worked out really nicely. There were no remainders, and so they came out really, really pretty. That's not always the case, okay? All right. Simplifying radicals that aren't perfect nth roots and involve something that deals with absolute value. And we might have to simplify them a little bit farther. So this is where things are going to start to get tricky. So if we have a root and it's like the nth root of a to the n, if n is odd, then the answer is just going to be whatever your a is. So we don't have to worry about it. But if we take a number out when n is even, so this number is even and this number is even, whatever comes out has to be put in absolute value if it's odd. And I'm going to show you what I mean. Okay. So here we've got the square root of 24. Now we only have to do that with variables, okay? We don't do it for actual numbers, but we look at the square root of 24. Now this is one we've done before. The square root of 24, we have to look for any perfect square in that number. We want the largest perfect square, so in this case, I can break this up into the square root of 4 times the square root of 6. The square root of 4 is 2, so this would become 2 rad 6. All right, the cubed root of 24. All right, this is different. So now I have to think of all my cubes. So the way I do this is I write down my cubes starting at 2. 2 cubed is 8, and 3 cubed is 27. So 3 cubed is too big. So I ask myself, is 8 a factor of 24? It is. So I can rewrite this as the cubed root of 8 times 3. Okay, all under the cubed root. And I know that the cubed root of 8 is 2, so 2 is going to come out, and I'll be left with the cubed root of 3. All right, so let's try this next one. It's a cubed root of 54. So I write down 2 cubed, which is 8, and 3 cubed, which is 27. Well, 4 cubed is 64, which is too big. So I need to see, is 8 or 27 a factor of 54? And it is. So I can rewrite this as the cubed root of 27 times the cubed root of 3. I'm sorry, the cubed root of 2. All right, the cubed root of 27 is 3, so my answer would be 3 cubed roots of 2. You got it? I know it's challenging. All right, let's try it with variables. Okay. So now the cubed root of x to the 5th. Okay, the index is odd, so I don't have to worry about that thing with absolute value. So what I'm going to do is I'm going to divide 5 by 3. Okay, so 3 goes into 5 one time. So x to the 1 comes out. But when it goes in, so 5 divided by, so 3 going into 5, it goes in one time, but there's a remainder of 2. So that remainder 2 stays inside. Another way of thinking about it is breaking up x to the fifth using cubes. So breaking it up like this, x cubed times x squared. Okay, so then we've got the cubed root of x cubed, which is x, but we have this leftover x squared that we can't do anything with. Okay, I know that was a lot. Okay, all right, let's look at this next one. And I think for this next one, you have to think about it in parts. So first we have to take the square root of 72. The square root of 72 can be broken up into the square root of 36 times the square root of 2. Okay? All right, so I'm going to do that first. So we've got 6. I'm going to leave room, root 2. Now I'm going to deal with the square root of x cubed. Okay? So I'm going to divide 3 by 2, and I get 1. So that x to the 1 is going to come out, and there's a remainder 2, so x squared comes, there's a remainder 1, so x will stay inside. Then I look at the square root of y squared. Well, we know that a square root cancels out the square, so the y will come outside. So I will get 6xy square roots of 2x. Hoi! Okay, now here's the problem. This y squared has an even exponent, and this is an even exponent, okay? So that means that y needs absolute values around it when it comes out, because we need to ensure that when we take it out, it is a positive number. Okay? All right, let's look at this next one. The square root of 20x cubed. This is even, this is odd, so I don't have to worry about the absolute value, but I have to deal with 20. So 20 can be broken down into the square root of 4 times the square root of 5. So 2 root 5. All right. Now, I've got to deal with the square root of x cubed, okay? So we divide 3 by 2, and we get x. It goes in one time. So we get 2x comes out, and we have a remainder of 1, okay? So 1x stays in. Again, if you really are having trouble with this, think of it as breaking it up into the largest cube, or square and cube. So it would be x squared x, right? So that way you're always going to have that like one remainder here that you have to deal with, but then it's the square root of x squared, which is x, which came out, and you have this 1 left over, which was right here, okay? All right, so I want you to try one. I want you to try the cubed root of 81x cubed and the cubed root of 54y to the 10th. So I want you to pause, try them, and come back, and then we're gonna end there, okay? All right, so you came back and you did the cubed root of 81. Well, 81 is not a perfect cubed, but I know that 3 cubed is 27, okay? So I know that 81 is 27 times 3, so I can write this as the cubed root of 27 times the cubed root of 3. The cubed root of 27 is 3, so I have 3. I'm going to leave room, cubed roots of 3. Now I've got x cubed. I divide 3. Remember the cubed root of x cubed, that cube undoes the cube. So I have an x that comes out. All right, 54. I know that 54 is a factor of 27. So I can rewrite this as the cubed root of 27 times the cubed root of 2. So that gives me 3. I'm going to leave room, cubed roots of 2. Now I deal with y to the 10th. I take 10, divide by 3. So 3 goes into 10 3 times. So y cubed comes out. There is a remainder of 1, and so y to the 1 stays inside. All right, guys, we're going to stop there. Now, I highly recommend that you rewatch this. This is hard stuff, but we're going to practice for the next couple of days in class. Have a great night.